Hi, everyone, and welcome to what I expect to be a really interesting session with Owen Garrett from Deepfence. For those of you who don't know who I am, I'm Shane Murnion. I'm an admin here on We Hack Purple community, and I'm also an OWASP chapter leader in Stockholm, Sweden, and I work normally professionally as an application security engineer. But tonight we're going to get a presentation from Owen, and Owen, if it's possible, could you start off with introducing yourself and Deepfence?
Yeah.
And then perhaps give us a bit of information about the structure of the talk, how you'd like your questions, that sort of
thing.
Yeah,
of course, Shane. Really happy to do that. And thank you, everyone, for taking the time to join us today. So I'm Owen Garrett. I work with the Deepfence team, looking after our products and community approaches. And what we're going to do over the next 30 to 40 minutes is discuss some of the challenges that users have when they're building and deploying applications into cloud-native environments and trying to secure those. We'll talk about the big disconnect that you see between what's done in engineering and development and the reality of what actually happens in production. I'm going to use this session to talk about an open source project from Deepfence called ThreatMapper. And ThreatMapper addresses this challenge, and it seeks to give tools that you can deploy in production that then work well with your development process and development teams, giving you insights that your development teams can act on. So that's what we'll cover. I'm really happy to take questions through the chat at any point. I won't be monitoring the chat, so I'll ask Shane just to jump in if there's a question that is very timely. And other than that, we'll come and as we wrap in half an hour's time, I'll go through and review the questions and we can talk about whatever it is that piques your interest or that you'd like to find out more about. So let's get going. I said that there was a challenge that you and your colleagues and your employers and the organizations you work with are trying to face. And the challenge is that your engineering, your development teams are equipped with modern, effective, well-targeted tools that they use in development, in CI, in CD, to scan applications, to look for vulnerabilities, to ensure that those applications, when they're ready to be deployed into production, are as secure as they possibly can be. But those tools fall short because it's not possible to eliminate every single vulnerability from an application. Threats can still exist. And on the other hand, your production teams, platform operations or SecOps, they have a wealth of tools. Some of these are a little bit more legacy focused. They're not quite as cloud native as the tools that your development team use. Those tools give the context of what the application's doing, who's accessing it, what events are being observed, but they generate huge numbers of alerts. And so how can you reconcile this? How can the production team effectively provide feedback to the engineering team about the biggest threats that their applications face and the actions that engineering can take in order to address those threats? So with this gap in place, and I don't know if this is something that you see within your organizations, the rich tools the development team have and the languages they use versus the language that production use and the maybe less effective tools that they have. But if this is something that you recognize and you see that there is a gap of understanding between development and production that's holding back the security of the applications, then maybe some of the platform technology from Deepfence can help address that. Deepfence, we're a global software provider. We manage a series of open source projects and one enterprise project, and we put ourselves in the space of security observability for cloud native applications. That's a little bit of a mouthful. If we unpack that, our belief is that you cannot secure what you can't see. You have to be able to observe what's happening to do effective security. So our tooling sits around observing what's happening to applications in production, the threats that they're facing, and it's specifically targeted towards modern cloud-native applications. We're open source first. We launched our open source project in October of last year. So it's been out in the community for about 8 months now. We're up to 1,700 GitHub stars for our primary open source project, and up to well over 3,000 GitHub stars across our portfolio of open source tools. And although I won't spend much time talking about it today, we do also have an enterprise add-on that adds some runtime security capabilities to the open source platform. It's still early days, of course, for Deepfence and for ThreatMapper, our signature open source project. As I said, been out, available to the community for about 8 months, but already picking up strong recognition from a range of different industry bodies. And what do? Our open source project does 2 things for you. Remember, we're rooted in observability. And one of the challenges that I hear about when I talk to users within our community is that they don't have sufficient visibility as to what is running in their production environment and how close that matches what their development team have built and staged to be pushed into production. So there's a disconnect there. They can't see what's in production and how it's being used in a way that is meaningful to the development team. And so our open source project uncovers that. It discovers what you have in production. It identifies the graph connections between those different components in production, creating an attack graph to show how different components can be addressed. And then it scans those, looking for vulnerabilities, secrets, and other types of threats, with a lot more on our roadmap, extending out the suite of threats that we can detect. With our open source project, we give you the observability over the security threats that your applications face in production. And with our enterprise product, we then layer on some runtime alerting to identify attacks as they happen in real time, map those back to the threats that we have learned about, and give you targeted actions on how you can remediate and protect against those threats and those attacks. The first thing that I hear, maybe this is something that resonates with you as you think about the security of the applications that you build and deploy into production, is that my development team has a very effective process in place.
Owen,
yeah.
Sorry to interrupt. I've got a really great question. Just hand it right away.
Yeah.
Does ThreatMapper work for cloud deployments, or can it be used in an on-prem deployment?
Yeah, great question. So as we go through the demo, I'll talk through how in detail it works with on-prem deployments as well. But the answer is yes. ThreatMapper supports multiple concurrent clouds and on-prem deployments. We'll look at the architecture. It works in a client server architecture where you deploy clients, sensors on your production platforms. They can be on-prem, they can be Kubernetes, they can be cloud. So the goodness that we'll share with ThreatMapper, you can apply that, whether you're deploying applications on bare metal hardware, in virtual machines, in Kubernetes, serverless with Fargate, or in Docker. So let's think about those applications that you're deploying into those production environments. And you or your engineering team may say, we use a suite of fantastic tools. We use GitHub or GitLab security scanning. We use DAST and SAST tools. We use Snyk or Tenable or other things. And we are confident, with a small set of known exceptions, that the applications we push into production don't contain any vulnerable components and the code's been scanned. Is that enough to ensure that my applications in production are free from attack? And unfortunately, the answer is that yes, this is a very, very important first step, but it doesn't go far enough. And we can look at that because we can think about what's the life cycle of a vulnerability. The most important point here is not that vulnerabilities exist. That's not news to anybody, or even that they're very, very prevalent, that large numbers of open source projects have had vulnerabilities in the past. That's just a fact of life. The thing that surprises me is how long it takes a vulnerability to be discovered, how long it takes then for the provider of the software developer, to become aware that that vulnerability exists, and then to push that out to their community of users. GitHub scanned the open source projects within their repo, tracking vulnerabilities when they were detected, working backwards to identify when that vulnerability initially appeared in the code, and found in their own scans of software libraries on GitHub, it took about 4 years between a vulnerability being introduced into code and it being detected, and then a further 12 weeks to then investigate, understand, remediate, push out a fix, and alert users that the fix is available. So there's a very, very big window of opportunity when an attacker when a vulnerability is discovered, that an attacker can seek to exploit it before users are able to patch it up. And if we look at the graph here, at any point in the pink part of the GitHub Octoverse report, if you had scanned your application, you would not have detected the presence of a vulnerability that existed. You would have confidently deployed it into production, only for that vulnerability to have been disclosed afterwards. We can unpack that. We can look at one of the great examples from the last 12 months, the Log4j issue. The Log4j vulnerability, probably the biggest single vulnerability we've seen, certainly since at least things like Heartbleed, was very, very long-standing within the space. It arose because, like a lot of enterprise Java modules, the developers, with the best will in the world, looked to build something that was flexible, extensible, and could be used in a wide range of different environments. Log4j processes log files, rather processes events and writes log files. And in order to help users extend it, the team built in capabilities using JNDI to configure Log4j dynamically. One capability allowed the Log4j module to pull a third-party Java module from a remote server and use that to process the log file. And of course, every time we think about something like this, there's a big danger that someone is able to find a way to exploit that particular code path using user-provided code or information. And a logging module is particularly susceptible to that because its job is to log user-provided data. The code was committed as part of the 2.0 project back in 2013, released, and the 1.x release was end-of-lifed shortly afterwards. So the entire world of Java applications that were using logging as part of their functionality picked up this 2.0 and subsequent releases. A couple of years later, at Black Hat, a presentation was made that speculated about the possibility of exploiting the JNDI resource lookup capability, particularly against the LDAP implementation, in order to manipulate Log4j to do a remote code execution. And that provoked a little bit of thought, a couple of code changes, but things really took off when someone reviewed that information about 9 months ago. There was discussion on GitHub in mid-November 2021. A proof of concept for an attack called Log4j shell was pushed out a couple of weeks after that. And then the exploit was the first public exploit was observed again about a week after that. The very first exploit involved an attacker using Log4j to send first a subtle request that sent back a beacon to try and obtain a resource that didn't exist. And by using that, they were able to spray huge volumes of web-facing applications in order to find vulnerabilities. And then having found that, they used that to then deploy a crypto miner on the vulnerable components. That was the very first exploit, but there have been many, many exploits since, and a large network of command and control systems set up in order to detect and then take advantage of vulnerable Log4j deployments. The community, of course, responded very, very quickly once the POC was made available and the exploit was known. There was a flurry of activity. You may remember, if you were tracking this yourself, the number of releases that were made. And in fact, the first fix was not a full fix. As people looked into this in more detail, they found multiple more issues. More CVs were published. Additional remote code execution or DOS paths were found. This is common for any major vulnerability. Remember I said with the GitHub example, they estimated it took a median of 4 years between a vulnerability being present and it being disclosed. Here we've gone from 2014 to 2021, so 7 years this vulnerability was available in the wild. So just scanning and deploying applications when you believe them are to be secure is not sufficient. The next stage that you should consider is building a bill of materials, an inventory of what's in those applications. So you could go back in time and say, a vulnerability has been disclosed. I want to look back through the historic SBOMs, software bill of materials, and identify applications that I've deployed. They were believed to be secure at the time, but which now have a component which is known to be vulnerable. So with a mature capability of generating SBOMs and reviewing those for your deployed applications, is that sufficient? It's a very, very significant step forward. But the fact of the matter is that what runs in production is not the same as what the development team staged to be deployed into production. When applications are deployed into production, they can be decorated, enhanced, extended in a range of different ways. Sidecars can be added, agents or additional integration may be embedded within those containers or applications when they're pushed into production. There'll be third-party container images and applications, so databases or monitoring tools or container agents that came from other sources that have found their way into production. And of course, there's the host infrastructure as well. Security wants to be able to shift left. Security starts at runtime and needs to be able to shift in towards production, CD, CI, and the source code. And development needs to be able to extend their ability to observe and control what's happening to the right. We want to provide, with the open source tools we have, the capability to observe what's happening at each of these stages with a particular focus on production and runtime. So the development isn't just limited to seeing what they've built and staged production, but they're able to see what is running in production and how it's behaving. And security isn't limited to having a black box view of a bunch of executables sitting in production with no awareness of what's inside those, but is able to move left to understand what's inside those executables, what are they made up of, and where vulnerabilities or threats may exist. So by providing the tools to observe what's happening in development and in production, then we can help you improve the security of your applications. So what I'd like to do is go through, for the bulk of this session, and go through it in action. ThreatMapper, as I mentioned, is an open source project. So we'll start from the very, very beginning. We'll deploy ThreatMapper against, and we'll use it to monitor a couple of production systems. And I'll show you what ThreatMapper is able to detect so you can identify what are the threats that you need to respond to. Let's begin with ThreatMapper on GitHub. So a quick search, find Deepfence ThreatMapper here on GitHub. And we begin with a helpful README that steps you through the processes of deploying the ThreatMapper management console and also deploying the agents against various production systems. Let's scroll down. How do we install the management console? Instructions are here. I'll copy and paste these into a machine that I've got up and ready we hack purple console. In order to get this running. So we take that and then we need to paste these guys. How does it work? We grab a Docker Compose file, and then the Docker Compose file references a series of images from Docker Hub of a pre-built management console. You can also build a management console from scratch. It takes a couple of minutes to start up. It's a relatively complex application with a number of different components. And the router component works a little bit like in Kubernetes, where you have a liveness or readiness probe. The router component will check that all of the other services are up before it admits traffic. So the first time you try and hit this host with an HTTP request, so it may take a second. If we look at the router process, router is there. So I'm still waiting for containers. Give it a moment. So typically 30 seconds to a minute for everything to initialize, Elasticsearch to get running, the various services to be going. And there we go. So the router now is ready. And we can hit our management console. And in we go. This is a fresh install. With a fresh install, you get the opportunity to register a new account. So let me put in a fresh password for this account. The very first user who registers will then have the ability to register other users. So once the first user is registered, other people can't come and use the console to register directly. They need to be invited. So we have our console. If we were to look at the topology graph now, it's essentially empty because we haven't deployed any agents. So let's then go and deploy a couple of agents, one on our Docker host and one against a Kubernetes cluster that I'm running. So again, let's find our Docker host here. We have a couple of processes running, or containers running on that host already, and I'm going to deploy the Deepfence agent, which authenticates itself to the management console we've just deployed using a key and sends telemetry back about the services and traffic that it's seen on the host that the agent's deployed on. We'll do the same with our Kubernetes deployment. So I'll add the Helm chart for the Deepfence sensor agent, and then install that again with the authentication keys. And this will call back to our management console. So there we go, up and running. Now let's have a look and see what have we found so far, observed so far in the management console. We look at DigitalOcean. We have a workload running in London, a workload running in Amsterdam. If I look at the Amsterdam workload, so Amsterdam Cloud, the WHP Docker workload has a couple of containers running within it. And if we give this a couple of minutes more, this will begin to derive some useful network information. But as we wait, the very first thing that we can do is start a series of scans against those containers running on the workload. So the log4j vulnerable app, fresh install, never been scanned. So let's trigger a scan for that. And for good measure, we'll start a secret scan. And let's do the same for the Nginx proxy. So we'll run a scan on that, and we'll initiate a secret scan. Now the ThreatMapper sensor will scan the containers, the file systems of the containers, generate SBOMs, and send those back to the management console where they can be inspected. The ThreatMapper agent, as you've just seen, also monitors network traffic. And here we've just observed on this workload, there are a pair of Nginx worker processes which are load balancing traffic to our Java application. The Nginx processes inside the Nginx proxy, the Java application inside the log4j vulnerable app. You'll remember we also deployed the agent using a Helm chart against a Kubernetes cluster. Here we go, 3 nodes in the Kubernetes cluster. And again, I could start a scan on those nodes. With Kubernetes, not only can I scan the containers, but I can scan the entire cluster. This will pick up SBOMs from the hosts that are running Kubernetes nodes, so we can scan those, and SBOMs from the various containers running within pods on that Kubernetes cluster. Let's kick that scan off, and then let's go and review and see if we've received any scan results yet. We look at our log of vulnerability scans. You can see the first 2 scans that we triggered have returned results. If we look at the log4j vulnerable app and the recent scan results from there, it's picked up a number of vulnerabilities, so 230 vulnerabilities in total, ranging from low severity across the base operating system and the Java service through to much higher severity vulnerabilities. We can also pull the SBOM that was derived for that, so we can see the packages and files that were discovered on that workload. Vulnerabilities in their own right are useful, but not particularly actionable. A very large list of critical vulnerabilities, in this case 47 in this one container alone, is typically too much to go through and try to remediate every single one of those. We'll come back and look at the way that ThreatMapper can prioritize vulnerabilities in a moment. But as we wait for the other vulnerability scans to complete, let's look at some of the other things that we triggered. We ran a secret scan. On the log4j vulnerable app, we find a couple of candidate exposed secrets. So again, looking for threats that are present on these workloads. We find things like a Linux password file, shell configuration file, and various log files judged to be of low and medium severity. It's normal to find those within containers and workloads, but those are things that you may wish to audit to verify there's no sensitive data within. If we look at the Nginx proxy, what have we found? So we find, again, password file, we find a private key, we find something that matched our session token scan, the regular expression for a session token. So again, things that you may wish to check and verify. And if you feel this is a false positive, then you can mask a particular secret match or threat out so it's not reported in future. So we're not worried about etc password. We already have processes in place to make sure that etc password is secure. As well as scanning running infrastructure, looking for threats, for vulnerabilities and exposed secrets, you can also point ThreatMapper at registries where containers are stored pre-deployment. Let's deploy it against a Docker Hub registry. So test registry running in the ONG namespace, and I'll just pop in the credentials for this. Try one more time. Go. So we've now authenticated the ThreatMapper console against a Docker Hub registry. ThreatMapper is now enumerating that registry, looking for images within that registry. And again, I could pick an image in the registry and I could determine that I could say, I want to start a vulnerability scan on that image right now. And indeed, I could repeatedly run that scan if I wished. When ThreatMapper identifies issues, of course, they're reported through the API and the user interface, but we can also post notifications out to Slack or to an HTTP endpoint or to Teams. We can raise alerts against SIEMs. We can raise tickets against Jira. We can archive data off host, and we can generate a series of management reports. But let's come back and look at the vulnerabilities that ThreatMapper so far has discovered within our production environment. You'll remember we started scanning a range of hosts. So these scan results are beginning, Kubernetes nodes. So these scan results are beginning to come in. And over time, we'll see additional container scans coming in as those scans complete. But 690 vulnerabilities thus far, 81 of these critical. As mentioned before, that's a lot to have to go through, parse, and prioritize. This is where the unique capability of ThreatMapper's attack graphs comes into play. You'll remember when we looked at the topology chart that ThreatMapper was able to track network traffic and identify the flow of traffic to determine, in this case, which services were receiving traffic directly from the internet, which services were sitting behind those services in a multi-tiered fashion. And by doing so, ThreatMapper is then able to deduce how individual services can be accessed and the level of threat that each of the vulnerabilities and exposed secrets presents. In our most exploitable vulnerability and top attack paths report, we show you which of the workloads are at most risk of being exploited because A, they have the highest priority critical CVEs or vulnerabilities present, and B, they are receiving traffic directly from the internet or from external sources. And we can track this through multiple tiers. So here, for example, identifying a Log4j app sitting behind our Nginx proxy is potentially vulnerable. ThreatMapper takes this information, the level of severity of the vulnerabilities that we've identified, the method of exploit, prioritizing vulnerabilities that are network exploitable, their proximity to the attack surface, to the internet, the evidence of live connections to those workloads, and indeed, if a live exploit exists for those particular vulnerabilities. And by blending all of this information together, we create for you a list of the most exploitable vulnerabilities. Here, flagging up issues with Log4j and JServe protocol as being estimated to be the vulnerabilities that pose the greatest risk of exploit within your infrastructure. So rather than dealing with 650 or more vulnerabilities across multiple different containers, ThreatMapper helps you zero in, drive in and identify specifically the vulnerabilities that pose the greatest risk to your infrastructure. Having seen it in action, we've deployed ThreatMapper, we've scanned our environment, we've optionally scanned registries, we have found vulnerabilities and other types of threats, and we've ranked those. Who's using it? ThreatMapper is entirely open source. There's no need to register. We have users who've identified themselves through our Slack support channel. We have users, and please feel free to join them on the set of stargazers, people who've recognized and bookmarked ThreatMapper. Closing thoughts. If you just focus on securing your applications as you go through development and deployment, then you've got a blind spot in production. There are threats which only exist in production, which cannot be detected in development or deployment. There are threats that were not known when an application was deployed into production and which were only disclosed afterwards. Our job with ThreatMapper is to build you a platform that identifies different types of threats, whether they're vulnerabilities, they're exposed secrets, or on our roadmap, the capability to identify configuration issues in cloud and Kubernetes environments and flag those up against your production environment. So you know you have a measured, assessed, and ranked list of what vulnerabilities and other threats need to be addressed first. And I mentioned our enterprise product, ThreatStryker, which layers on an additional set of capabilities to then provide real runtime protection to prevent those threats from being, or help prevent those threats from being exploited. So if you want to find out more, do find us on GitHub. Please give the project a star. Find us on our community Slack. Use ThreatMapper to help identify the blind spots that you have as you look at the security of your applications. So I promised you a quick run through of ThreatMapper. It's been great sharing it with you. I'd love to hear any thoughts on whether this is something which is addressing needs that you're aware of right now, whether it's now or later on. So I'll take a break now. We'll jump through, we'll have a look and see what's popped up in the chat. And yeah, let's take it from there.
Oh, and actually I have a question immediately there, which struck me that, I mean, recently in my own company, we've done analysis of the different secret scanners that are out there, and there's not terribly much in the space, actually, to be honest. And it seems to be an awful lot of it is locked into source code. Like if you're using GitHub, then you have secret scanners. Very little of it actually addresses the situation, what's happening out in the production world after deployment. And it seems to me that this product actually fills an enormous hole right there, actually.
We do indeed, yeah.
So I had a question related to that, is in that how the secret scanner, is that configurable? Or how do you build the rules? Is it regular expression matching or how does it work?
So our secret scanner is based on an open source project, again from Deepfence, called Secret Scanner. Not too much of a surprise. So you'll find us again on GitHub. And we've integrated the secret scanner into the ThreatMapper platform. So it's one of the types of threats that we're able to detect. And you're right, Shane, it is broadly regular expression based. There's a large database of signatures that we pull from and that we run against your environment. And yes, we run it against running containers or containers staged in registries, or indeed against the file system of running hosts. So it's not limited to development. It works in production. We looked at it earlier on. We picked up a couple of minor potential issues for the Log4j app. Let's take a little look at what we found here. So here I scanned our Nginx image and we found a couple more potential issues. What you would do typically is review this and determine, are these real issues that I'm concerned about, or are these issues that I would want to mask out? Maybe I've already got a good process in place to make sure that my etc passwords are always secure, so I could mask that record so it never pops up again. And this way you can go through and you can iteratively improve the accuracy of the secret scanner by filtering out stuff that it detects that you're not concerned about. Oh,
so you can actually implement a sort of false positive control.
Yes.
To refine the results it's generating. That's absolutely essential. That's fantastic.
Yeah, it is, because secret scanners tend to be really noisy because the patterns can match a lot of legitimate data as well.
Because generally, like, I mean, we find that we've never been able to find just one tool that fits all our needs. So we generally try to employ as many as possible, depending on. But our main concern is often that we don't want to extend the time within the CI/CD pipeline within the build process. But this doesn't affect your build process at all. It's actually happening after the fact.
That's right. So you can run it during your build process. We do have a little agent you can pop into your CI pipeline if you want, but that's not the core purpose of this technology. We're all about taking these good practices that you probably already do in CI and replicating those in production. The reason being that sometimes if you do something in CI, it's too early.
Yeah.
And it's necessary to protect in depth and repeat and extend these tests within production as well.
And also, I find that organizations have a sort of blind spot in that they're only running these tools on products that are under active development.
Yeah.
You know, as you say, once things are pushed out to production, you can have an application that's running for 8 years. You know, it's super stable. They've never needed to update it. And so they're not actually looking for all the vulnerabilities that have occurred in those last 8 years.
Yeah, that's exactly right. They're only scanning the things that they have actively built. They were probably not scanning the infrastructure they've deployed. So here, for example, we have a workload. So this is a host. WHP Docker. It's running a couple of containers. And of course, we can scan these containers as you'd expect. And you would do that in your CI process. But I can also pick that host. And I can decide I want to scan that host as well. This will scan the base file system of the host. In a Docker case, it won't scan the containers. In a Kubernetes case, you saw that you could.
Yeah.
So you can extend your scanning. So it's not just what you see, what you build with your development team. It's also the infrastructure that you run on, giving you greater coverage.
Yes, because one of the again, a lot of the tools that are focused on the CI/CD pipeline, they're all about tools we're building ourselves, not about, like, for example, when Log4j turned up, a lot of organizations was trying to work out, of all the products we've bought that use Java, how many of them have this vulnerability? And often it involves a lot of sort of ring around, talking to vendors, trying to find out what's actually installed on the, get a full bill of materials and BOM in your production server. And this seems to me that this would take an awful lot of pain out of that process of, because you're automatically getting reports on not just your own built software, but even the third-party applications that you've bought.
Yeah, that's right, Shane. So it's not immediate. There's a little bit of work to be done, just to set expectations. The way that the architecture works is that you deploy our sensor agents on the things you wish to scan. So if you have a Java application that you've deployed on a Linux host, and that's the application you deployed 8 years ago that you've got no way of inspecting, then absolutely you can use ThreatMapper to look at it in real time. And you would do that by deploying a Docker runtime on that host and then deploying the agent, just as I did a couple of minutes ago here, for example. So just deploy the Deepfence agent, and then your legacy application is up and running, and it will appear in the Deepfence UI as one of these topology components, so as a workload, and you can then trigger scans on that workload.
It's amazing. It's brilliant. By the way, everybody, I've set the settings. So if anybody wants to ask a question, they can certainly unmute themselves. Feel free if you want something you'd like to push directly to Owen at this time. And while
this is Preeti here.
Yes.
So as we talk about threats in production, now consider a case where the organization is looking at threat modeling in itself as a potential solution. Now, apart from the regular SAST, DAST, or the other controls in the pipeline, if an organization is also is performing a threat model, how different would ThreatMapper be in that case?
So ThreatMapper gives you a baseline set of information on which you can build your threat model. You can use ThreatMapper to then pull out bills of materials. So for example, when we scanned, in fact, let's grab it from here. So when we scanned the book info container, again, I can pull the software bill of materials. So I can take offline, I can understand what's deployed, what are the packages on those, what are the files. So that gives you good baseline information. If you then want to know what's happening in real time, this is where the enterprise product, ThreatStryker, comes in. And with ThreatStryker, in addition to doing these vulnerability and other kinds of threat scans, we also track alerts. So here, for example, we've tracked alerts that we have observed within your application. So we can see that traffic is coming in from the internet through HA proxy to the Log4j component. And we can track alerts that we have seen that have affected that. So we could look at traffic that's hit that Log4j component and understand what sort of attacks it's facing, what sort of attack traffic is coming in.
Got it. So, again, one more question. When you talk about, ThreatMapper being hosted on-premise or on cloud. It's not just about the code that is being written within the organization. Now, I might be buying X number of products from a vendor, and I might be using it. Say, for example, I'm buying a product from IBM, and I just want to host it on one of my servers. Now, I do agree that IBM is a reputed organization, but I still would want to take a little deeper into the particular product that I'm buying from IBM. So, would ThreatMapper still be able to do its analysis on this product that I intend to put? I mean, the one that it's a commercial product that I'm hosting it on one of my cloud servers. Would that still work?
So Preeti, if you could install the ThreatMapper agent on the host, then yes, it would work. And the ThreatMapper runs within a Docker runtime on that host. You've got control of the Linux host that you've installed this IBM product on, for example. Then you've also got sufficient control to deploy a Docker runtime, deploy the ThreatMapper agent. The agent talks back to the management console, and then from the management console, you can initiate security, vulnerability.
Okay. That's interesting. Thank you, Owen.
Hey, you're welcome.
Is there anybody else who's got a question for Owen while he's in the hot saddle? Owen, I'm curious about one thing. Yeah, I mean, you're a commercial company, and then you're investing all this time in a free product. It seems a bit counterintuitive. Why are you building an open source product, or why aren't you selling the product?
Well, there's a couple of reasons. The most important reason is that we all benefit from secure applications. I'm sure we've all had instances with family or friends of identity theft or other kind of things that could have been avoided if developers had built applications in a more secure fashion. There's a common goal within the security community to help people build applications in a secure way and to help them manage and operate those securely. And it's right and proper that that technology is available to everybody without the barriers of cost. So I'm really happy that we are making this core technology available to anyone. It's built on community knowledge about vulnerabilities and threats, and it's available to the community at no cost, entirely open source. Then there's the obvious question, is this purely philanthropic? Are we doing this just out of the goodness of our heart? Of course, there must be a commercial side to it. And yes, the commercial side comes from when you need to respond to a vulnerability or a threat that we have detected. You can look to remediate that yourself, or you can look to a range of different technical measures to try and secure or seal off that vulnerability. And our ThreatStryker enterprise product, the paid-for product, is one of those tools that you could use to protect yourself from exploits of that vulnerability. So the general understand the threat map of that your organization faces is entirely open and free and open source to all. The specific task of protecting your application against detecting vulnerabilities, we can then layer that on top with our enterprise product.
Well, I'm very glad. You did both. Owen, we have a question from Mandeep, and he's asking, I guess, can the agents be applied to web services? So I guess that's both REST or perhaps older VCF services that are running in a Windows environment or on Azure cloud.
So currently the agents run on hosts, and we only support Linux hosts in production. We do have an experimental Windows implementation, but it's not something I'd recommend for production. So if you're running Linux-based VMs in Azure, then yes, we can help to scan those and identify threats in those VMs. In our roadmap, we have some really interesting capabilities around detecting threats that result from cloud configuration errors or configuration weaknesses. This is agentless. This is coming in a future release, and Azure will be one of the platforms that we're going to support. And the plan is that this will come out within our entirely within ThreatMapper open source. So there's stuff coming in the roadmap, Mandeep, that may help you to help secure your Azure environments as well.
I guess it would be a challenge to analyze, for example, serverless functions. They're going to be off to one side.
So serverless, again, with engineering work in place to look at this. For Fargate workloads, we can do that. You can deploy our agent as a sidecar container on your Fargate workload. We haven't quite got Lambda yet. We are working on that. So yeah, we're working, and it's an open source project. We welcome all contributions. So if someone wanted to have a look at how they could apply, for example, apply the agent to a Lambda function, we'd love to work with people and help understand and implement that solution.
Actually, Owen, that's a really good point, perhaps, to bring up at the end here, in that the We Hack Purple community is often, there's quite a lot of new beginners who are trying to come into the application security sector. And I suspect often the question I get asked from people who are starting out is, how do I prove my capability? How do I prove my application security knowledge? And a wonderful way, if you have a developer's background, is actually working on open source tools. And this is a perfect example.
Yeah, we'd love to have people taking a look. The very first thing to do is to find us on GitHub, star us, join the community. So you'll find the links across here, and we have a Slack channel. So start with that, and then if you come across problems, if there are problems in deploying or operating ThreatMapper, come to our community, and we'd be very, very happy to help. If you hit what you think is a bug or a potential improvement for ThreatMapper, then please throw an issue our way. We use GitHub to track those issues. And if you'd like to jump in and grab one of those issues and try and address it, then yeah, we'd love to work with you on
that. Is there anybody who has a last question before we finish up with this session? I'd like to, if anybody has a question, they can just jump in. But in the meantime, I'd just like to say, Owen, absolutely amazing. I'm really, really impressed with the product, and fantastic that you could give a live demonstration. I know these things can be tricky. And it's certainly something I know we will absolutely be looking at the use of this tool in different aspects in our organization. So thank you very much. I really appreciate it.
All right. Shane and team, thank you very much. It's been a pleasure chatting with you. Come and find us at deepfence.io, find us on GitHub, give us a star, try the project out, give us some feedback. We'd love to work with you.
I hope you can come back and give another presentation, either through We Hack Purple, or else I'll possibly invite you to come along to one of our OWASP in Stockholm meetings, because I think this is a significant product, and it should be of interest to a very large sector in the application security sector.
Yeah, thank you. I'd love to take that invite up sometime soon.
Okay, well, I guess we're out of time. So I'd just like to thank everybody here who has watched with the same fascination as I have. We have recorded the presentation, so after a short while, we'll probably be pumping it up to one of the We Hack Purple channels, where it'll be available to the wider public. So thank you very much, Owen. We really appreciate your presentation today. And thank you very much for turning up and showing interest.
Yeah. Thanks, everyone. Cheers.
Take care.
Thanks, everyone.
Good night.
Thank you.